Alright, today we are going to talk about chemical names and formulas, which we're going to use a lot of the information from bonding to help us, because there's going to be two different types of things. Now, just as a reminder, this is a chemical symbol that we have seen, and we always use the element abbreviation, and the subscript indicates that this has two hydrogen atoms, and then we've got our symbol for oxygen, and the subscript tells us that there's one. Now we know that the name of this molecule happens to be water, but we're also going to learn the formal fancy version for all of these because not all of them are going to be common to us. Alright, now this is also a little bit of review, but when we have a compound that is covalently bonded, or a molecule, or a molecular compound, it is covalently bonded. And this happens between two non-metals. Okay, and it's the number of atoms in the compound represents the number of atoms of each element contained in a single molecule of the compound. So this is, since the electrons are being shared, we use these lines to indicate where the electrons are being shared, and they're kind of floating back and forth between those two atoms. This is a ball and stick model of nitrogen dioxide, where you've got a nitrogen and two oxygens, and then over here you have carbon, two hydrogens stuck to it, as well as two chlorines stuck to it. Okay, and we're going to learn how we would name those molecules here in just a minute. Now, what we refer to, binary means two, molecular means covalently bonded, and this is always going to be between two nonmetals. So again, you got to go back to the periodic table and remember that if this is our, or my really bad rendition of the periodic table, we've got the stair-step line right here in the middle. Excuse me, when we talk about two nonmetals, we're talking about these guys in here as well as hydrogen. Okay, so those are the big ones when we talk about the nonmetals, and why we know. Because the formula does not always show the simplest ratio, it shows the actual composition of the molecule. And this is going to be a different set of rules for how we name these compounds. Now, it's all driven by electronegativity. We should remember from Unit 5 that electronegativity is a measure of how strongly an atom attracts electrons when it's in a compound. I also liked to refer to this as the electron tug of war. Okay, we saw electronegativity really dictates whether or not something is covalent or ionically bonded anyway, but this applies only when an atom is in a compound. We've already learned this, but fluorine is the most electronegative element. It's assigned a value of 4.0. All others are determined by comparison, and you've got that electronegativity chart. Now, with naming molecular compounds, the less electronegative element always goes first. We only give it a prefix if there is more than one. Okay, so for all of these in the molecular version, you're going to hear us talk about prefixes. The first one's only going to get a prefix excuse me, if there's more than one. The second element is the more electronegative element, and it will always get a prefix, and it always has an IDE ending. And the formal fancy definite version is the A or O is dropped at the end of a prefix if it's the root of a vowel. If the root of the element is a vowel, and I'll show you some samples of these, but this is kind of the least of our worries. We got to get down the rules first, and then we can get picky. Okay, as for the prefixes, and you've got to memorize these. Most of them at least make some sense. Mono is 1, di is 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. So you just have to know these in order to successfully do this skill. Now, you're going to see, naming one of two ways. It's going to be like this one, where you're given the formula and you got to come up with the name, or in a minute you're going to see where I give you the name and you got to come up with the formula. Okay, for this first one, we have to figure out what two elements we're dealing with. The P is for phosphorus and the F is for fluorine. Now, for the first element, there is only one, so it does not need a prefix. So the name of this compound would be phosphorus, and then there are 5 fluorines, so it's going to be penta, and then we change it to IDE. So this would be phosphorus pentafluoride. Okay, again, 2 non-metals, so that's why we use our prefixes. Okay, the next one we've got is xenon. There's still only one, so in the first atom, so we do not need a prefix. We've got 4 fluorines this time, so this time it's going to be tetra. Oops, we're in that space here. tetrafluoride. Okay, and last but not least, you've got CCl4. This would be, excuse me, carbon, only one of them, tetrachloride. Okay, so carbon tetrachloride. Now here's what I mean the opposite, where you're going to be given the formula, or sorry, be given the name and you have to come up with the formula. So for the first one we're dealing with carbon and we're dealing with oxygen, and there's no prefix on the first one, so the first is simply going to be carbon dioxide is O2 because the di means 2. Now here we finally have one with a prefix in the beginning because there's more than one, so it's going to be N2 for dinitrogen. Pentoxide, this is what I was referring to when we dropped the vowel, is that we may have written pentaoxide. Honestly, I'm not necessarily going to mark you wrong for it, but the correct version here is pentoxide, and we dropped that A. But it's still going to tell us that there are 5 oxygens because pent or penta refers to 5. For sulfahexa, hexa is going to be 6. So you've got sulfur, and then you've got 6 fluorides. Okay, and that's it for covalent. When you have 2 nonmetals, that's when you're going to use the prefixes. Alright, so now let's switch, and then in the next video, what we're going to talk about